sweet like a buttercup. You're a Barbie doll. Show them all what I'm made of. Strut down the hall. Won't stop till I get enough.
You know how much we all love those amazing space discoveries, right? Well, I actually dug up this NASA press release from way back in 2015 about the Kepler mission. And we are going on a deep dive today into Kepler-452b, a planet so similar to Earth, they nicknamed it Earth's older, bigger cousin.
Oh, yeah.
So are you ready to unpack this?
Absolutely. I am. This is a huge discovery because Kepler-452b wasn't just any planet, similar in size to Earth. This was the first confirmed near-Earth-sized planet, and it was found in the habitable zone of a star very similar to our sun.
So habitable zone, for anybody who needs a little refresher, means it's that Goldilocks region, right, where the temperature could be just right for liquid water to exist on the surface.
Right. Yeah.
But I'm curious, what makes the type of star so important here?
Well, think about it this way. A planet's environment is heavily influenced by the star it orbits.
Right.
Kepler-452b orbits a G2-type star, just like our sun. That's a really big deal because it means the energy this planet receives is comparable to what Earth receives, which increases the chances for a similar environment.
And get this, Kepler-452b's star is 1.5 billion years older than our sun.
Yeah.
That just makes you think, what could that possibly mean for the development of life on this planet?
It's a fascinating question. If life arose on Kepler-452b, it would have had so much more time to evolve than life on Earth.
Right.
However, older stars also get bigger and hotter and brighter over time.
Oh.
This means Kepler-452b might have experienced a drastically different climate, in its past.
Oh, wow.
And it could face a much hotter future.
Like a cosmic time machine.
Yeah.
Showing us a potential glimpse into Earth's future.
Exactly.
And, the press release has these illustrations comparing the Kepler-452 system to our solar system.
Yeah.
Kepler-452b's orbit is nearly the same size as Earth's, so it takes roughly the same amount of time to orbit its star, 385 days.
Right.
Almost like looking in a mirror, except one reflecting a much older version.
It is tempting to get caught up in the similarities, but it's important to remember we're working with limited information.
Yeah.
We don't know Kepler-452b's mass or composition for sure.
Right. We can't get ahead of ourselves, but how can scientists even begin to make educated guesses about a planet so far away?
Well, based on its size,
Yeah.
which is about 60% larger in diameter than Earth,
Okay.
it's categorized as a super-Earth.
Yeah.
And previous research suggests that planets this size have a good chance of being rocky like Earth.
Okay.
But to confirm this, we'd need to determine its mass, which is a real challenge given the distance.
Okay, so it could be rocky, and it's in the habitable zone of a sun-like star. What would it take to learn more? I mean, it is 1,400 light years away.
That's the real hurdle.
Yeah.
Studying Kepler-452b directly is incredibly difficult with our current technology.
Wow.
Even with incredibly powerful telescopes, it's just a tiny dot in the vastness of space.
Right.
This 2015 discovery was based on data collected between 2009 and 2013.
Wow.
So just imagine the technological leaps we've made since then.
So this deep dive is really just scratching the surface, isn't it?
Absolutely.
There's so much more to uncover about Kepler-452b and the possibilities it represents.
Absolutely. This discovery opened more doors than it closed. What's truly fascinating is what this tells us about the potential for other Earth cousins out there just waiting to be discovered. It sparks our curiosity and pushes us to keep exploring.
Yeah, it really makes you think, if we found Kepler-452b using data that's over a decade old, what else might be hiding in that data just waiting to be found?
It's exciting to consider, and with newer telescopes like the James Webb Space Telescope, we're entering a new era of exoplanet discovery.
Okay, before we get lost in the possibilities of future discoveries, let's focus on what we do know about Kepler-452b.
Right.
We've talked about its size, its star, its orbit, but what would it be like to actually visit this planet?
That's where things get even more interesting. We've only just begun to explore the potential of this distant world.
So if we could somehow hop on a spaceship and travel all the way to Kepler-452b, what would we experience? What would it be like to stand on its surface?
Well, remember how we talked about Kepler-452b as super-Earth, meaning it's bigger than our planet?
Yeah.
If it is rocky, like we suspect its gravity would be a lot stronger than Earth's.
So instead of feeling like a graceful astronaut, we'd probably feel more like we're just wading through molasses.
Exactly. Every step would take more effort. And if we could even jump, we wouldn't get very high. But let's say we do acclimate to that increased gravity. What would we see when we look up at the sky?
Yeah. Would it even be a blue sky like we're used to?
That's a great question. Remember, Kepler-452b orbits a star that's older and brighter than our sun. The sunlight reaching the surface would likely be a lot more intense, and it might have a slightly different color, maybe a bit more yellow or orange.
Okay, I'm trying to picture this. So instead of a bright blue sky, maybe it would have a sort of pale yellow tint. And what about the sunsets? Would those look different too?
Now that's where things get really interesting. We don't know the exact composition of Kepler-452b's potential atmosphere. But imagine combining a thicker atmosphere, perhaps, with different gases, with the light from an older, yellower star.
Whoa, the sunsets could be unlike anything we've ever seen.
Exactly.
Yeah.
It really pushes our scientific imagination. How could scientists even begin to model something like that, given what we know about atmospheric physics and stellar evolution?
That's a question for the experts, for sure. But let's talk about something a bit closer to home, at least in terms of what we're used to. How long would a day be on Kepler-452b?
Well, we know its orbital period. Its year is about 385 days, pretty close to Earth's. But the length of its day is still a mystery. It can be tidally locked to its star, meaning one side always faces the star and the other side is in perpetual darkness.
Oh, wow, I hadn't thought about that. So if it's tidally locked a day on Kepler-452b, it could be the same length as its year.
Exactly. Imagine living on a planet where daytime lasts for over a year. What kind of impact would that have on the development of life, on weather patterns, on the whole concept of time itself?
It makes you wonder what kind of adaptations life would need to survive in those kind of extreme conditions. Would there even be a concept of night as we know it?
Those are exactly the kinds of questions scientists are grappling with, and that's what makes Kepler-452b so captivating. It forces us to confront the limitations of our own planetary experience and imagine possibilities that seem almost like science fiction.
But even if Kepler-452 isn't a perfect Earth twin, isn't the fact that we found it so significant? I mean, this is just one system that we've studied in detail, and there are billions upon billions of stars out there.
You're hitting on a crucial point. The discovery of Kepler-452b isn't just about finding one potentially Earth-like planet. It's about the broader implications. It suggests that planets like ours, in orbits that could allow for life as we know it, might not be as rare as we once thought.
It's like finding a single grain of sand on a beach and realizing the beach stretches on for miles.
Exactly. And while Kepler-452 might be out of reach for now, its discovery has paved the way for future missions and telescopes that are designed to study exoplanets in even greater detail.
So what's next for the search for other Earths? What are some of the most exciting developments on the horizon?
Well, even though the Kepler Space Telescope has been retired, scientists are still analyzing the vast amount of data it collected. We're likely to see even more exciting discoveries come out of that data in the coming years. But we also have a new generation of telescopes coming online.
The James Webb Space Telescope, right? The one everyone's so excited about.
Yes. The James Webb is far more powerful than Kepler and can analyze the atmospheres of exoplanets looking for signs of gases that might indicate the presence of life. And there are other missions in development, like the Plato mission by the European Space Agency, which will focus on finding Earth-sized planets around sun-like stars.
It sounds like we're on the verge of some truly groundbreaking discoveries.
We absolutely are. We're moving from simply detecting exoplanets to characterizing them, understanding their atmospheres, their compositions, and their potential for harboring life.
It's incredible to think how far we've come in such a short time. Just a few decades ago, we didn't even know for sure if there were other planets outside our solar system. Now we're finding potentially habitable worlds and developing the technology to study them in detail.
It's a testament to human ingenuity and our insatiable desire to explore the unknown.
Yeah.
And who knows, maybe one day we'll even develop the technology to travel to these distant worlds and see them with our own eyes.
Now, that would be truly mind-blowing. But for now, we're left with the tantalizing glimpses provided by telescopes and the boundless possibilities that Kepler-452b and other exoplanets represent. So where do we go from here with this specific planet? What are some unanswered questions that you find particularly intriguing?
Well, for me, one of the biggest mysteries is the potential for life on Kepler-452b. We know it's in the habitable zone, we suspect it's rocky, and we know its star is similar to ours.
Right.
But we don't know if it has an atmosphere, what that atmosphere is made of, or if there's any liquid water on its surface.
It's like having all the ingredients for a cake, but not knowing if anyone actually baked it. We have the potential, but we need more evidence to confirm whether life could truly exist on Kepler-452b.
Exactly. And that's what drives scientific exploration. We have these tantalizing clues, and we're driven to find more answers to piece together the puzzle of this distant world.
So what would it take to get those answers? What kind of technology or missions would we need to really delve into the mysteries of Kepler-452b? It seems like we need a whole new generation of technology to get a closer look at Kepler-452b. But even with our current limitations, what are some things that scientists are focusing on to learn more?
Well, analyzing the light that passes through a planet's atmosphere can tell us a lot about its composition. If Kepler-452b does have an atmosphere, future telescopes might be able to detect the signatures of gases like oxygen, methane, or water vapor,
Okay.
which could be potential indicators of life.
So like a fingerprint revealing the planet's secret.
Precisely. And it's not just about the presence of certain gases, but also their ratios and how they interact. It's a complex puzzle, but each piece we find brings us closer to understanding the bigger picture.
Yeah, this is where my brain starts to melt a little. What kind of advancements in telescope technology would be needed to analyze an atmosphere that's 1,400 light years away?
We're talking about telescopes with incredible sensitivity and resolution, capable of capturing the faintest glimmers of light passing through a distant planet's atmosphere. Some concepts are already being explored, like space-based interferometers that combine the light from multiple telescopes to achieve much higher resolution.
It's mind-boggling to think about the engineering feats that would be required to build something like that. But let's say for argument's sake that we do find evidence of an atmosphere and maybe even signs of potential life on Kepler-452b. What then? What are the next steps?
That's when things get really exciting. Confirmation of potential life on another planet would be one of the most monumental discoveries in human history. It would spark a wave of new research missions and international collaborations. We'd want to learn everything we could about this life, how it evolved, how it functions, and how it compares to life on Earth.
I can already imagine the headlines, "Scientists discover life on distant planet." The world would go crazy.
It would be a paradigm shift in our understanding of our place in the universe. It would force us to confront the possibility that we're not alone, that life might be far more common and diverse than we ever imagined.
It's almost too big to wrap your head around. But let's bring it back to Earth for a moment. What would the discovery of life on Kepler-452b mean for us here on our own planet?
It would raise profound questions about the nature of life itself.
Huh?
It would challenge our assumptions about what's possible and inspire us to think more creatively about solutions to our own planetary challenges. Imagine the collaborations that could emerge, the new technologies we might develop, all spurred by the desire to understand life beyond Earth.
It's like that spark of inspiration that comes from looking up at the stars and realizing how much more is out there. And speaking of looking up, this discovery was made using data that's over a decade old. What are the chances that we've already gathered even more compelling evidence about Kepler-452b and other planets that we just haven't analyzed yet?
The possibilities are truly tantalizing. There's so much data waiting to be explored, hidden within the archives of missions like Kepler. Who knows what hidden gems are waiting to be discovered, what new planets, what new possibilities.
So this deep dive into Kepler-452 is really just the beginning of a much larger story, a story that's still being written.
Exactly. It's a story about human curiosity, our drive to explore, and our enduring fascination with the unknown. It's a story that pushes us to look beyond ourselves, beyond our planet, and to contemplate the vastness and wonder of the universe.
It's a story that reminds us that even in the face of seemingly impossible distances and technological limitations, the pursuit of knowledge and understanding knows no bounds.
And that in itself is an incredibly inspiring thought. It's a thought that should encourage us to keep looking up, keep asking questions, and never lose sight of the wonder that surrounds us.
Well said. I think we've covered a lot of ground in this deep dive into Kepler-452b. We've explored its potential, its mysteries, and the incredible implications of its discovery. We've talked about the technological hurdles and the scientific dreams that drive our exploration of the cosmos.
And while we may not have all the answers just yet, I think this journey has given us a glimpse into the incredible possibilities that await us as we continue to explore the universe and search for other worlds like our own.
Absolutely. So to our listener, as you continue your own exploration of the cosmos, remember to keep that sense of wonder alive. Kepler-452b is just one small piece of a much larger puzzle, a puzzle that we're all invited to help solve. And who knows, maybe one day we'll be having a deep dive into a planet that's not just similar to Earth, but a true mirror image teeming with life and ready to welcome us into its embrace. Until then, keep looking up, keep dreaming big, and never stop exploring.
Sound the alarm. I'm coming up. We'll have a ball. I'm sweet like a buttercup. You're a Barbie doll. Show them all what I'm made of. Strut down the hall.